we are going to talk about another question, which is a cyclist. A cyclist is moving on a circular path, on a circular path with constant constant speed v, with constant speed v. What is the change? What is the change in its velocity after after it has described an angle of 30 degrees? So we need to find this. So, and the options are v square root of 2, other is v by 1 half, v into 1 half, and another is v square root of 3, and finally is none of them. So the last option is none of them. So let's read the question once more. A cyclist is moving on a circular path with constant speed v. So it's not talking about the velocity, right? It's talking about the speed. The speed is constant. The velocity is not constant, since velocity is a vector and it changes with direction. And when you're moving in a circular path, you change direction. So we will also talk about that. What is the change in its velocity after it has described an angle of 30 degrees? So let's draw the figure. Since the cyclist moves on a circular path, I'm gonna make a circle. Let's make that one more time. So to make it a perfect circle, yep, this is the way to make a perfect circle. Let's use the gray. I think gray will look nice. Let's make it dotted, since this is the path it's gonna move. Let's also make a cyclist, because why not? So let's make a cyclist, or a cycle, and there is a cyclist, right? So a cyclist is moving around this path, in this circular path. So let's remove this. I'm just showing that there was a cyclist. Let's say there was a cyclist. So let's say the cyclist moves from here. Let's not do that. Rather, let's make it a point. I think a point would be much more better. So a cyclist moves from here to here, and moves in such a way that, let's say the cyclist was originally here from the center. Let's make this white, and let's make this that thick, and he goes from here to here. Let's make this blue, and this point is the center. So this is the center. So this is the center, and the center, you can represent it by any coordinate system, and I'm going to represent this to be 0, 0, since you can say anything is 0, 0. If you don't have a coordinate system already predefined, you can define 0, 0 anywhere. So a cyclist moves from here to here. So he moves from here to here, and he moves from an angle of 30 degrees, right? He has a speed of v. So let's say this is our vector of velocity. So this is the velocity vector. This is the velocity vector. That's the velocity. So since there is an arrow, so there is a direction. So this is the velocity. But if you were talking about the speed, so I'm gonna write this in another color. Let's do gray. So if you're talking about the speed is v, right? And if you're talking about the velocity, it's gonna be v with an arrow. And if you're just talking about the speed, it's gonna be v, right? Now, we need to talk about a few things, which is what is the change in velocity after it has described an angle of 30 degrees. So the velocity is going to go from this. So this is going to be the first velocity. This is going to be the first velocity. The magnitude of velocity is still going to be v, right? So that's something that's going to remain constant. But once this rotates from here to here, it's not going to stay like this. It's going to move like this, since the velocity is tangent to this line. It is tangent to this line. And so let's you don't actually need arrows on this line, so I'm going to not make them arrow. let's make them smaller as well. So I'm just showing that these are moving. So we have this vector and this vector. Let's say this vector is vector v2, and the magnitude of this vector is still gonna be v, since the speed is constant. The velocity changes but the speed is constant. So let's just take these two vector. So I think you understand the image, right? So you understand what the image is trying to see. Now what I'm gonna do, I'm gonna take this vector, I'm also gonna take that vector, right? And this and that vector. Now a thing that you should know is that this angle is 90 degrees. So the angle between this line going to here and this is supposed to be 90 degrees. It might not look like it, so let me make it look like 90 degrees, but this is supposed to be 90 degrees. You will just have to trust me on this one, and this is 90 degrees. We will learn why in some video, but not today. So this is 90 degrees, okay? So since this is 90 degrees, when it moves from here to here, the angle between these vectors is also gonna be 30 degrees. So this is gonna be 30 degrees, okay? Since that is 30 degrees, now we have, we need to find the magnitude, we need to find the change. So the change is gonna be from v1 to v2, right? So let's make this vector to show the change. Let's make it red in color. Let's make the weight this, and this is the change, okay? So this is gonna be the change. So this is the change. So what the change is, and the change is gonna be from vector. So the change vector is gonna be from vector v2 minus vector v1. So that's the change. If you want to show the direction of where it's moving, so that's the change. But if you're just asking the change, you don't need to specify direction. I'm just specifying to make it much more clear and much more visually understandable. But it's a quick thing that I also want to tell you is that the direction of change, there is no such thing as direction of change. I'm just showing this direction of change to show that if a person was here, he moved from here to here. It's basically like that. So this is a change. So now let's check out what to do. So we just need to use the formula, right? So let's use that. Okay, so let's use the formula. I think you remember the formula. I'm going to write it change instead of vector c, since that's going to be a hassle, and just writing change is much more clear. So the change is going to be square root of e square. So e square is going to be v square, v1 square or v square plus b square minus 2ab cos theta. So cos theta is going to be 30 degrees in this case. Now let's just do some quick math. Cos 30 degrees is going to be square root 3 by 2. So this is going to be 2v square minus 2v square square root 3 by 2. This value of cos 30 degrees is something that you just have to learn. So sorry, I would say it's just something that you must know. So if you just do this, the 2's will cancel each other out. Now if we take v square as common, you get v square bracket 2 minus square root of 3, and just by this step I can tell you that the answer is D, none of the above, since I don't think any of this will give us the answer that we want, right? So this is going to be 2 minus square root of 3. So we got this as the change, and if you look at the options, there is no such option, so the answer is none of them, right? So this was the answer. I think this is a very interesting question, since some of you might think that the result in is the change is just going to be from here to here, but we are talking about the change in its velocity, not the change in its position. If you talk about the change in its position, so listen to me, if we are talking about the change in its position, it's going to be from here to here, change on its position, and you will have to take these as the length, which is going to be the radius, right? But if you talk about the change in the velocity, it's going to be from here to here, if that makes sense, right? I think that makes sense. So I think that's pretty clear and pretty understandable. And also, since the center was no use for us, I don't need to mention that center is at 0, 0 as well. Okay, once more. If I told, or if the question said change in its position, you will have to go from this point to that point. Whereas if you were told that the change is in velocity, it's going to be from this point to that point. I think that makes a lot of sense. And also, position is sometimes also represented by delta v. So you can also do it like this. So the change c, which I'm representing, which is just a symbol that I chose randomly, you can also write it like this and it will still be valid. It will also be recognized as change. So this is going to be it for today's video. On the next video, we're going to do another question. So till then, bye bye.